Welcome to qnawire.
So we want to find mass, and we know that mass is equal to the double integral of the density ds. So first we want to find density, which we know because we're given, and then we also want to ultimately find mass. So since we're given that we can assume that z equals r because z equals the square root of x squared plus y squared. So since z equals r and our density is 10 minus z, what we'll have here is 10 minus r. And we'll copy and paste this so we can keep the formula up. So it's going to be 10 minus r. And then we want to determine ds. So what we'll do is we'll parametrize this. We'll let x equal x, y equal y, and z equal f of xy. So doing that, we end up seeing that ds is going to be the square root of what we'll do is the partial derivative. How ds works is it's the partial derivative of z with respect to x squared plus the partial derivative of z with respect to y squared, and then plus 1. So with that in mind, we recognize that the partial derivative of z with respect to x will be x squared over x squared plus y squared. And then the partial derivative of z with respect to y will be y squared over x squared plus y squared squared. And that's after we square everything. So this is what we'll have. And then as a result, we can combine the like terms, and what we'll end up with underneath the radical is 2 over x squared plus y squared, or 2 times x squared plus y squared over x squared plus y squared. So our ds is equal to the square root of 2. Then we can plug that in here now, square root of 2. And since we changed the polar coordinates, we now need to make this r dr d theta. And our bounds, since it's a circle or in polar coordinates, we'll have 0 to 2 pi. And we know that z is from 1 to 4, so that's what we'll do here. Then we can just make this m for mass. We know that if we just evaluate these integrals separately, we can pull this square root of 2 out. We can put the d theta right here. This will give us, as a result, we'll get 2 pi. This will be times 2 pi. And then this right here will be 10r minus r squared. So we'll get 5r squared minus r cubed over 3. When we evaluate those at 4 and 1, we will end up getting 59 as our result. And we end up getting this answer right here, which is equivalent to 108 times the square root of 2. If we look, we'll get 108 times the square root of 2. This will be 118 times the square root of 2 pi. And that will be the final answer that we get.